Okay, let's take a look and let's go a little bit further into our square roots. What do I need to do with the square root of all this mess? What's that? Divide it like how? Divide it all by 2? Okay, cut it in half. Yeah, okay. So let's do this. Just like I can take the square root of 3 times the square root of 2 and turn that into the square root of 6, and I can put square roots together, can I take square roots and pull them apart? Square root of 24, square root of x to the 4th, square root of y cubed. Can I do that? So let's do square root of 24. 2 and 12, 2 and 6, 2 and 3. What's going to be my set of pairs from 2, 2, 2, 3? Pair of 2s. So I'm left with 2, and what's left over? Do I have a pair for that 2? Hello? No. Do I have a pair for that 3? No. So that's just together as a square root of 6. What do I do for square root of x to the 4th? Who can tell me? X what? X and, okay, x and x cubed, x and x squared, x and x. Do I have a pair of x's? Yes. Another pair of x's? Yes. So I have 2 pairs. The other way to think about it is, if I have x to the 4th, what is half of x to the 4th? X squared. X squared, 2 of them. Now, what if I have 3 y's? Y. What every kid says about algebra. Y. That's right, it's a joke, you can laugh. If there are 3, do I have a pair? I got 1 pair of y's, and what's left underneath? Okay, could I leave the answer like this? Yeah, I could. Is there a better way to write the answer? Put all the stuff that's not in a square root up front, put everything that's left underneath. Can we do that? Right there is your best answer, right there. Now, again, what can I do here? Just like I can pull them apart, what can I do here? Good, so I have the square root of, what's the number? Yes, what's the number of x's? I got how many here? How many here? Total of? Got it. How many here? 3. How many here? 1, so total of 4. What can I do with my y's? Square root of y to the 4th is? Y to the 2nd. Square root of x to the 4th is? Love it. And 48. Didn't we have that one earlier? No, we did not. Square root of 48. So here we go. 2 and 24, 2 and 12, 2 and 6, 2 and 3. Pair of 2s, leftover 3. So what's this pair of 2s? 2 times, which is 4. How many left over? Root 3. You'll notice I'm putting all my roots at the back. I'm putting all my roots at the back so that you're not confused to think like up here that x squared is actually underneath the square root. So I'm putting all the square roots all the way at the back. So there you go. Let's do this one. Well, again, it's together. Can I break it up? Square root of 25 is? And the square root of 16 is? Ooh, not 8. 4. So I get 5 over 4. What's the only thing I need to do? Plus or minus. So I can break it up. A quotient can be broken up top and bottom and do each separate. So let's do it here. I get square root of 7 over square root of 9. Well, what's the square root of 7? Don't know. I don't either. Let's leave it square root of 7 because it doesn't break down. What's the square root of 9? 3. Plus or minus. There it is. All right. Let's go down here to number 12. Number 12. What do I do again? Root it. Square root of 9 over square root of 7. What's square root of 9? Close. Plus or minus 3 all over square root of 7. Now, folks, you cannot leave your square roots like this. This needs to be rationalized. Rationalized, which means no roots in the denominator. No roots in the denominator. Now, folks, is it okay if I multiply this by 1?
Yes.
What would it be if I multiply it by 1? The exact same thing. Could I multiply this by 7 over 7 if I wished?
Yes.
Because if I do the same thing to the top as to the bottom, does it stay exactly the same?
Yes.
Good. Now, what if I say square root of 7 over square root of 7? What is that divided by that? Well, 1, so I'm good. But now, what does that make the top? Be careful. No, it is not square root of 21 because the 3 is not in a square root. The 7 is. So we say, no, we say 3 root 7 because 1's under, 1 isn't. They got to stay separate. But let's look on the bottom. What do I get square root of 7 times square root of 7? Are they both under the square root?
Yes.
Can I say, what's 7 times 7?
49.
So can I say the root 49? But what is the root 49?
7.
So there we go. Now do I have a square root in the bottom anymore? No. Here we go. Let's do another one. What is the square root of 42 over square root of 6? Now, could I break those up, Hunter, top and bottom?
Yeah.
Yes. The problem is 42 a perfect square root?
No.
No, that's a mess. Is 6 a perfect square root? No, that's a mess. Can I simplify it without breaking it up? What is 42 divided by 6, people?
7.
Oh, can I get rid of my fraction by just doing the division? Okay, so I get square root of 7, and I'm done. Because can I take the square root of 7?
No.
No. Okay, now let's do this one. What about this one? Square root of 24 over square root of 12.
Root 2.
Root 2. Yes, you're correct. It is root 2, and here's why. Could I take 24 divided by 12?
Yes.
And that leaves 2, so it's root 2. Here's the other way you could think about it. 24, 2, 12, 2, 6, 2, 3. I get a pair of 2's with a 2 times 3 left underneath. 12 is 2, 6, 2, 3. 2 comes out front with a root 3 left over. What can I reduce? The 2's and the root 3 is leaving root 2. There you go. So that is just basic roots. Now, let's go ahead and do another one. I want to rationalize this because what's wrong?
There's a root in the denominator.
There's a square root of 5 in the denominator. So what do I multiply top and bottom by to get rid of it?
5.
Okay. So what is root 5 times root 5? Anyone yell it out? Root 25. No. Well, it will in a minute. So we have 4 root 5 over root 25. So what is the root 25? Close.
Plus or minus.
Plus or minus. And what's now on top?
4 times 5.
Now, folks, I told you can't have, when it's rationalized, a root in the denominator. You'll notice I still have a root in the numerator. That's fine. Nothing wrong with that. Now, I have a problem with number 15. Do I have a root in the denominator?
Yes.
There's still a problem, though, because I can't just multiply by root 2. Because if I just multiply by root 2, I get 3 root 2. But because there's a plus sign, what do I need to do with that root 2? Give it away. So I would end up with root 2 plus root 4. So I could fix this and turn it into 2, but now did I just create a root 2 problem? Yeah, I'm still left with a root in the bottom. That's no good. So that doesn't work. Here's what you have to do if you have a root with a plus or minus in the bottom. You're going to multiply just like we did last time. And it's going to involve a root 2, but it's also going to involve the 1. Here's how it works. It's called the conjugate. the conjugate. And instead of 1 plus root 2, you're going to multiply by 1 minus root 2. But if I do it on the bottom, I must do it to the, thank you. Now, what do I have to do with a 3 outside parentheses?
Apply it. Or multiply it.
Yeah, apply it, multiply it. 3 minus 3 root 2. Did I give it away to each piece? So, down here on the bottom, do I have a 2-parter times a 2-parter? 2 parts times 2 parts. What do I have to do with 2 parts times 2 parts? Multiply it out. What's 1 times 1? 1 times negative root 2, not Nathaniel. 1 times negative root 2. Negative root 2. Once I'm done with that, give this away. What's root 2 times 1? Close. Root 2. Now, what's this going to be? Positive root 2 times negative root 2. Negative root, close, 4. What happens to negative root 2 and positive root 2? They cancel. What is root 4? 2. So I have 3 minus 3 root 2 all over 1 minus 2, which is negative 1. There you go. Let's do one more like it. Top and bottom, what do I multiply by? Zimmer. 2 plus root 6. 2 plus root 6. What do I have to do to the top, Mr. Ripple? What do I have to do to that 5? Expand it. Give it away. I love it. 5 times 2 is? Good. 5 times root 6, Ripple. 5 times root 6. Be careful. 5 root 6. So it's 5 times root 6. I can't put it together because one's outside, one's inside. It's not plus, it's times. Good. Now what do I need to do to the bottom, ladies and gentlemen? 2 times 2 is? 4. 2 times root 6. Not plus. 2 times root 6. 2 times negative root 6. What's 2 times negative root 6, Chalmers? Good. And what is negative root 6 times positive root 6, people? Well, as it get positive and negative makes it negative. Root 6 times root 6 is root 36. What happens to the 2 middle pieces? Good. And what happens to root 36, Mackling? Close. You're so close. Not root anymore because you did the root. It'd just be regular old 6. So I have 10 plus 5 root 6 all over 4 minus 6. What is 4 minus 6, people? There you go. Negative 2. There it is. That is the answer.